Okay, so in the part 3, let's try to work with the so-called general form of the equation of a circle. Work with the general form of the equation of a circle. Okay, so what is the general form? So check here. We have this example from last two examples. X plus 3 squared plus y minus 2 squared is equal to 16. Okay, I said when you try to find the standard form of the equation, you do not expand it. Okay, so you do not expand it. Leave this as your final answer if your question is to find the equation of the circle. And this time, let's try to expand it, see what it is. Okay, so if we expand this, remember a plus b squared is a squared plus 2ab plus b squared, and a minus b squared is a squared minus 2ab plus b squared. Okay, that's to general formula. Now let's apply the first formula here. So it's x squared plus 2ab, 6x plus b squared, 9. And second, you apply the second formula. Y squared minus 4y, 2 times y, and plus 2 squared, 4, is equal to 16. All right, so that's the expansion after you expand it. Actually, you see here, this one is very clear. From here, you can directly read the center and the radius. And here, you can still read the radius at this moment, but the center becomes very confusing from this formula. Let's continue the computation. Here, you have 9, 4, 16. You move 16 to left side. So you get x squared here, y squared, 6x minus 4y, 9 plus 4, 13, minus 16, minus 3 equal to 0. Okay, so this is the stuff. And this number, and this number, we are going to use A, B, C to represent. X squared, y squared, they are just x squared, y squared. They have no coefficient. So x squared plus y squared and plus ax. Here, when I point out 4, actually I mean negative 4. Remember, every time when you have a coefficient of a term, you include the sign. So it's a plus by and plus c equal to 0. Okay, so this type of equation, it can represent a circle. I don't say it always represents a circle. It can represent a circle or a point. With some extreme case, it may represent a point or nothing. Or there's no solution. This does not represent anything. Okay? So for example, if you let A, B, C are all 0, this is represent a point. The point is the origin, 0, 0. Only x equal to 0, y equal to 0. The sum of squares equal to 0. And this one, when A is 6, B is negative 4, C is negative 3, it will represent a circle. It represents nothing, it's easy. So you can just put x squared plus y squared and plus 1 equal to 0. Then this one represents nothing. No xy satisfy this equation. We always talk about real numbers. Okay? So again, unless we mention we're using the complex number system, we always unless we say we use a complex number system, we always use the real number system. In the real number system, this does not have any solution. Okay? So what is the general form. So far we just studied the example and get some formula. What is a general form? Let's see the definition. One, its graph is a circle. The equation x squared plus y squared plus ax plus by plus c equal to 0. This equation is called the general form. Of the equation of a circle. When it represents a circle, then it's called it. For example, this one is not the general form of an arbitrary circle. It's just a point. This one does not represent anything. So for some good selection of A, B, C, this is called the general form of the equation. Not for all A, B, C. For some, one. Okay? So this is the general form. You have x squared, y squared, you have x, y, z. Square term and the linear term. Okay? So that's how the general form. Here, in the circles, general form, standard form are different. This is standard form. Standard form always represents the circle, but the general form sometimes represents circle, sometimes not. Okay? And for the line, general form, standard form are the same thing. Okay? Okay, let's see the example. Example, graph the equation. Graph the equation x squared plus y squared plus 4x minus 6y and plus 12 is equal to 0. Plus 12 is equal to 0. Okay? Okay, so to graph the equation, we need to, basically this one will represent the circle or point or nothing. So in general, it will represent the circle, right? So we need to find the center. We need to find the radius. So if it represents a circle, we need to find the center under the radius. Center under the radius. So we need the standard form. We need the standard form. Only from the standard form we can find the center under the radius. Okay, so let's compare this problem with the first one. So actually, we are going to start from the third row and go back to the second equation and then go back to the first equation. How do we get? We are going to, you see here is the x constant, y constant, and another constant. So here I'm going to combine, put the x terms together. So we put the x squared 4x together, and we'll leave a space. We will do some magic, and put the y squared minus 6y together. Okay. Now let's see. Add 12. At 12, we don't change it. Now let's see. You have an x squared x term, but you don't have this 9. What is a 9? 9 is actually 3 squared. 3 comes from 6 over 2. Remember here it's a 2ab, so b is equal to 3. So here is a 4. So 2ax. 2ax is 4, so a is a 2. So I'm going to need this number 4 here. Okay? I need a number 4. It's artificial. You need the number 4 from left side, you put number 4 on the right side to balance it. Okay? Okay, so here's plus. This plus is still plus. And y, you see, the same thing. Minus 2by. It's always 2ab minus. So b, 6 is 2b, b is 3. 3, you are going to need 3 squared 9. 3 squared 9. You put a plus 3 on the plus 9 on the left side, you put a plus 9 on the right side. Okay, so that's a magic. So here, those two numbers are from this formula. How do you get those numbers? You divide this coefficient by 2 and square it. So 4 over 2 is 2, square is 4. 6 over 2 is 3, square is 9. You add those two numbers on the left hand side, you also add it on the right hand side. Okay? Okay, then let's simplify. This one, the first 3 terms becomes x plus 2 squared. And these 3 terms becomes y minus 3 squared. And plus 12 is, this is a 13. Sure, you are going to move 12 to the right side. You're going to get x plus 2 squared and plus y minus 3 squared is equal to 1. 13 minus 12 is equal to 1. Okay, so this is the standard form. This whole process is to complete square. Complete the squares for both. Okay? Okay, so from here we know the center is, remember here we are going to put x minus negative 2 for the first term. So the center is negative 2 and 3. Center is negative 2 and 3. The radius is r equal to square root of 1. It's always square root. Okay? Don't forget to take square root. The right hand side is not r, it's r squared. Square root of 1 is still 1. Okay, so that's a center and a radius. You get the center, you get the radius, let's sketch it. Negative 2, negative 1, negative 2. Positive 3, 1, 2, 3. This is a center. This is a center. We determine negative 2 and 3. And then let's sketch it. The radius is 1. Go up 1 unit. This is top point. Go down 1 unit. Bottom point. Go right 1 unit. Right point. Go left 1 unit. Left point. Okay, so this is a small circle. Circle centered at negative 2, 3 with radius 1. Okay, so this is the exercise related to general form. Again, general form makes sense when it represents a circle. Only when it represents a circle is called the general form of a circle. Otherwise, whenever you have an arbitrary equation, it may not be the general form of a certain circle. Okay? It could be one of those two cases. All right? So, well, let's see. In this part of an exercise, there are some very, very interesting problems, like geometric problems. Let's do 2 of them. So on page 186, there is 36. Let's try 36. 36, it's a problem in the sequence of problem. Find the standard form. Find the standard form. Of the equation of the circle. Okay, so center is 1, 0, and containing the point -3 and 2. Okay, so let's just randomly draw it. Assume you have a circle. Center is 1, 0, containing some point -3, 2. In order, okay, so let's do it. In order to find the standard form, you have a center, you need a radius. Here, containing means the circle contains the point. The point is on the circle. So we need to compute the radius. What is the radius? This is the radius, the distance. The distance between the point and the center is the radius. So the radius is square root of x minus x, x coordinate minus x coordinate squared, y minus y coordinate squared, and square root. This is the radius. Okay? Okay, then let's just compute what it is. So -3 minus 1, -4. -4 squared, 16. This is -4. -4 squared is 16. 2 minus 0 is 2. 2 squared is 4. So square root of 16 plus 4 is square root of 20. Okay? So after you get this r equal to square root of 20, then by the standard form, is x minus center, x coordinate, plus y minus y coordinate is equal to r squared. Square root of 20 squared. Square root of 20 squared is 20. So x minus 1 squared plus y squared is equal to 20. This is the standard form. Okay, so this is the standard form. So in order to write the standard form, you need center and the radius. Center and the radius. Okay. This is 36. Let's try 40. 40, yes. Same thing. Find the standard form of the equation of a circle. So it has addition. Here, 36 says you have center like this, and 40 says with endpoints of a diameter at 4, 3, and 0, 1. Okay, so endpoints of a diameter at 4, 3, and 0, 1. Okay, so that's another geometric condition. So this part from 35 to 42, they are all about translation from geometry to algebra. Okay, so what is the diameter? Diameter means you draw the segment through the center. Then this segment is from one point on the circle to another point on the circle. So this whole segment is called a diameter. This whole thing is called a diameter. Diameter is, you see here, this is radius, this is radius. Right? From the center, a point to the center, the distance is radius. From center to another point, the distance is a radius. So the diameter has length what? 2r. Diameter has a length 2r, twice of the radius. That's one property we need to know. Diameter always has length twice of the radius. So we have radius. And the center is the midpoint of the endpoints of a diameter. Okay, so you have this point, you have this point, you connect them, and this is a center, and it is also the midpoint of them. You see? Center is the midpoint of the diameter. So those two geometric conclusions are very important for the solution of this problem. Okay, so let's apply those two geometric condition. Okay, so first, the length. Length is the distance between those 2 points. So it's a square root of x minus x squared plus y minus y squared, square root. This is the length of diameter. It is equal to twice of the radius. Okay, that's a translation of the first condition. The distance of 2 points is equal to twice of the radius because they form the diameter. Okay, now let's try. So it is 4 minus 0 is 4. 4 squared is 16. 3 minus 1 is 2. 2 squared is 4. So it's a square root of 16 plus 4. So square root of 20 is equal to 2r. So we get r is square root of 20 over 2. Okay, so leave it there. Leave it there. Second, the center is the midpoint of those two endpoints. The midpoint, let's recall what is the midpoint formula. The midpoint of the points x1, y1 and x2, y2 is x1 plus x2 over 2 and y1 plus y2 over 2. It is the average. The coordinates are the averages of the corresponding coordinates. X is the averages of x1, x2. Y is the averages of y1 and y2. Okay, and this midpoint is exactly the center. So the center is, you have x coordinate plus x coordinate divided by 2. You have y coordinate plus y coordinate divided by 2, so which is 4 plus 0 is 4 over 2 is 2. 3 plus 1 is 4 over 2 is 2. The center is 2, 2. Okay, see, this is the center. And then what's next? Then you get the standard form. X minus x coordinate square, y minus y coordinate square is equal to r square. R square, a ratio square means a numerator square, 20, denominator square, 4. 20 over 4 is a 5. So it's x minus 2 square plus y minus 2 square equal to 5. See it? So this is the answer. Okay? And let's see one more. 42. We're still looking for the standard form of the equation with the given condition. The center is is 4, negative 2, and tangent to the line x equal to 1. Okay, so this one we need the graph. We have to carefully draw it and understand. Okay. One, 2, 3, 4. This is 4. 1, 2, 3, 4. 4, negative 2. 1, 2, negative 1, negative 2. 4, 1, 2. This is center. 4, negative 2. And the tangent to the line x equal to 1, x equal to 1 is this line, vertical line. Tangent means it touches it. So you see here, this just touch. This situation means the circle is tangent to the line. If you have this is not tangent. This just intersect. Okay, cross the line, cross. Okay, tangent to the line. You see, this is exactly the radius. When you have tangent, a circle tangent to the line, from the center to this touching point is exactly the radius. And also this radius is perpendicular to these tangent lines. They form a right angle. Okay, they form a right angle. That's a geometry. So okay, so here, if we try to sketch the graph, oops, it's bad. Okay, if we try to sketch the graph, you will see that, remember I said the radius is all perpendicular to this tangent line. So we already have a center. We need the radius. What is the radius? This is the radius, because x equal to 1 is a vertical. So only horizontal line is perpendicular to this vertical line. So this is the radius. And it is horizontal. This radius is horizontal. You see here, we use the geometry, vertical, horizontal. For the horizontal line, the distance you only measure in the horizontal way, x way. X is from, this is 1. It's from 1 to 4. So the radius r is equal to, from 1 to 4, the radius is 4 minus 1 equal to 3. Okay, 4 minus 1 is equal to 3. This is 3. Radius is 3. Center is 4, negative 2. The standard form is x minus x coordinate square plus y minus y coordinate square is equal to r square. So it's x minus 4 square plus y plus 2 square is equal to 9. And this is it. Okay, so this problem, this 42 is difficult. It's because you need to know this geometry. And the 38 is similar to this one. Try to understand it. Okay, so the radius perpendicular to this tangent lines. Okay, so that is the exercise I want to specifically emphasize or mention, because they highly depend on the geometry. You may or may not know the geometry behind the problem, so I try to discuss. Anyway, if you have any questions about problems from 35 to 42, you can ask me. They are all about the geometries, okay? They are required for the exam. Okay, very good. Thank you. We finished this section. We are going to start a new section in the new video. Thank you.